Good morning, students. We will now continue the remaining parts of carbon and its compound. We will continue this carbon and its compound. So far, we have discussed how to form covalent bond between non-metals. Now we will categorize organic compounds in different groups. But before we start categorizing, let us learn the counting of chemistry, in which meth for 1, H for 2, pro for 3, but for 4, pent for 5, hex for 6, hept for 7, oct for 8, non for 9, and deep for 10. The counting is furthermore, but we will learn only this because this is sufficient at the level of class 10. So students, we will categorize the organic compounds in different groups, and in the nomenclature of each group we will find alk. Alk will be replaced by the number of carbon atoms. For one carbon atom, alk will be replaced by meth. For two carbon atoms, alk will be replaced by eth. For 3 carbon atoms, alk will be replaced by pro. For 4 carbon atoms, alk will be replaced by 4. For 5 carbon atoms, alk will be replaced by pent. For 6 carbon atoms, alk will be replaced by hex. In this manner, we will nomenclate the organic compounds. First of all, we will start from saturated hydrocarbons. Saturated hydrocarbons. Hydrocarbons are those organic compounds which are made up of hydrogen and carbon only. There are two types of hydrocarbon. Two types of hydrocarbons. Number 1, saturated, and number 2, unsaturated. We will now learn group by group. The first group of carbon is alkane. ALKANE, alkane, whose formula is CnH2n plus 2, where N equal 1, 2, 3 and so on. In this formula, the number of hydrogen atoms is 2 more than twice the number of carbon atoms. For example, let us write molecular formula. IUPAC में structural formula structural formula. Full form of IUPAC is International Union of Pure and Applied Chemistry. These days, the names of organic compounds are decided by this institution, is decided by IUPAC. Therefore, the name of organic compounds is called IUPAC. Here, if we have one carbon atom, then the number of hydrogen atoms will be 2 more than the number of carbon atoms, because there is one carbon, so twice of 1 is 2, and if we add 2 to this 2, it becomes 4. It means the number of hydrogen atoms will be 4. So this is a molecular formula CH4. Its IUPAC name will be given by the group name alkane. The number of carbon atoms in this molecular formula is 1, and the counting in chemistry for 1 is meth. So as I have earlier said, al in this group name alkane be replaced by meth. In this manner, the IUPAC name of this molecular formula will be meth for alk, and the remaining spelling of alkane ANE will be sufficient. It means the IUPAC name of formula CH4 is methane. If we try to write its structural formula, there is one carbon and there are 4 hydrogen atoms all about carbon atoms will be placed. And hydrogen shares only 1 electron, and its bond with any other atom is always a single bond. So each carbon atom will be attached, so each hydrogen atom will be attached by carbon with single bond, this also single bond, this also single bond, and this also single bond. Carbon has a valency 4, so all the bonds in total of carbon must be 4. Here if we count the bonds, this is 1, 2, 3 and 4. Carbon shows tetravalency, so all the bonds altogether of carbon must be 4. Hydrogen has valency 1, so its bond with any other atom must be a single bond. So this is the structural formula of methane. If we want to write the electron dot structure of methane, we can write this in this manner. Where there is single bond, we will write 2 electrons. So we will write 2 electrons here, and thus in this circle there will be hydrogen, 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 and in this circle there will be carbon. This is the electron dot structure of methane. Carbon has completed octet, and hydrogen always completes duplet. Hydrogen always completes duplet, and remaining atoms completes octet. In this manner, even in covalent bond, each atom obtains the structure of its nearest inert gas. If we take the C2, if we take the number of carbon atoms 2 in this group, the number of hydrogen atoms will be 2 more than twice the number of carbon atoms. As here the number of carbon atoms is 2, its twice will be 4, and then we add 2 to 4, it will become 6. That is, the number of carbon, the number of hydrogen atoms will be 6, and its IUPAC name will be written by replacing alk by counting number 2, whose meaning in chemistry is eighth. It means for carbon two carbon we will replace alk by eighth, and its name will be eighth, and then suffixed by ane, and it will be read as ethane. And the structural formula of ethane will be written like this: two carbon atoms each bonded with single hydrogen atoms, thus completing tetravalency of carbon and monovalency of hydrogen. This is the structural formula of ethane. In this manner, we can write propane, butane, pentane, hexane, heptane, octane, nonane, decane. And in this group, that is in the alkane group, all bonds between any two atoms will be a single bond only. This group is of saturated hydrocarbons. This belongs to saturated hydrocarbons, and in saturated hydrocarbons, the bonds between carbon and hydrogen is always single bond. This is the recognition of this compound in the group of alkane. In this similar manner, we will come next. Alkene. Its structural formula will be like this, where n equal 2, 3, 4 and so on. The next group is alkene. In this group, the molecular formula will be CnH2n. That is, the number of hydrogen atoms will be twice the number of carbon atoms in this formula. Here, the number of carbon atoms will start from 2. What happens if we start from 1? Let us see. Let us do the rough. If we have one carbon, according to this formula, the number of hydrogen will be 2 twice. And if we try to complete structure, only 2 hydrogen will be added by a single bond. We see that hydrogen has completed its monovalency. This hydrogen as well has completed monovalency, but carbon has completed only divalency. Though its valency is 4, it should have 4 valency. Therefore, this compound is not stable. This cannot be formed. But if we start from 2, that is, if we write 2 carbon atoms, then the number of hydrogen will be 4. This is molecular formula. IUPAC and structure. And structure. If we have the number of carbon atoms 2, the number of hydrogen atoms will be 4. It's IUPAC. In alkene, alk will be replaced by 8 because the number of carbon atoms is 2. If the number of carbon atom is 1, alk is replaced by meth. I repeat. If the number of carbon atoms is 2, alk replaced by 8. If the number of carbon atoms is 3, alk is replaced by pro, and so on. Here, in the molecular formula, the number of carbon atoms is 2. So, in the group name alkene, alk will be replaced by 8. And remaining spelling ENE will be suffixed. Then, the IUPAC name is ethene. If we try to write the structural formula, here carbon. First of all, let us put single bond in all hydrogen and carbon. But by doing this, we find that this carbon atom has not completed its tetravalence because it has completed only 3, 1, 2 and 3. Here also this carbon has completed 1, 2 and 3. This should be wrong because carbon has valency 4 and it should be satisfied by valency 4. So to satisfy this, we will make this single bond double bond. And if we look at this, then we find that the carbon has 4 valency 1, 2 and 2, 4. In this carbon also, we will count all around it 1, 2 and 2, 4. This is the proper structural formula of ethene. We can write the electron dot structure like this. If you let us write this hydrogen, carbon, this hydrogen and this hydrogen. Here there is single bond, so it will be a pair of electrons. Here also a pair of electrons. Here also a pair of electrons. Here also a pair of electrons. But here between carbon and carbon there is double bond, so we will put here 4 electrons. And in this manner, if you see that hydrogen has completed duplet, this carbon has completed octet, and this carbon as well has completed octet. So in this manner we can proceed by increasing the number of carbon atoms like this. If we have 3 carbon atoms, then the number of hydrogen will be 6, because in this group the number of hydrogen atoms is twice the number of carbon atom. Its IUPAC name will be, this all will be replaced by 3 means pro, and its IUPAC name will be pro suffixed by EN, it will be read as propane. And in its structural formula, we will first write 3 carbon and 1 double bond between 2 carbon atoms. And by hydrogen atoms we will complete its tetravalence. Carbon has 2 valency, so 1 hydrogen, 3 and again 1 hydrogen, 4. This carbon has 3 valency, here 1, 2, 3, it should be 4, so we will add 1 hydrogen. This carbon has 1 valency, it should be 4, so we will add 3 more hydrogen. Now if we count, we will find that all the carbon atoms have completed tetravalency and all the hydrogen atom has completed monovalency. In this manner, we will write other molecular formula like butene, pentene, hexene, heptene, octene, nonene and decene. But up to class 10, it is sufficient to write up to 5 carbon atoms. This group is not a saturated hydrocarbon. This group is unsaturated hydrocarbon. Why? In hydrocarbon, if you don't have all the bonds single, then it is unsaturated hydrocarbon. At least one bond must be 2 or 3. But in saturated hydrocarbon, all the bonds are single. So the compounds of alkene group are all unsaturated hydrocarbons. And next one we will write next one will be alkyne. Here alkyne, this is alkyne group. In this group, the number of hydrogen atoms is 2 less than twice the number of carbon atoms. And where n will start from 2 as it has started in alkene group. First of all, if we put two carbon atoms, then the number of hydrogen atoms will be 2 to the 4 minus 2. This is C2H2, the molecular formula, and its IUPAC is alpha will be replaced by 8 for 2. So this alpha will be replaced by 8 suffixed by YNP, read as ethine. This is ethine. Some other people can read it as ethine. Both are correct. Ethine, in its structural formula, there is one triple bond between carbon and carbon, and the remaining bonds will be completed by hydrogen. Here, as carbon has completed 3 bonds, it must complete 4. So for this we will add 1 hydrogen, and here for this as well we will add 1 hydrogen. If we compare the number of carbon atoms and number of hydrogen atoms here from the molecular formula C2H2, we will find that the numbers of atoms are same in this structure, and all the atoms have completed its relevant bond. Hydrogen has completed single bond, and carbon has completed tetravalence 3 here and this one. For this carbon, for left side bonds and right side bond, all will be counted all together. So this 3 and 1, this becomes 4. For this carbon as well, this 1 bond and this 3 1 completes 4. So the carbon has completed its valency. And next one, we can write C3H4. If we have put 3 for n, the number of hydrogen atoms will be 2 less than twice 3. 3 2 is 6 minus 2 4. So the molecular formula will be C3H4, and it will be read as propine. For 3 we write pro suffixed by YN. This will be read as propine. If you want to write the structural formula, we will write 3 carbon in a row, and between 2 carbon atoms we will put triple bond, and in remaining we will put single bond. And now we will complete the tetravalency of carbon by hydrogen atoms. This carbon has 3 valencies, so we will add 1 hydrogen. Now its valency has become 4. It has completed tetravalency 3 here and 1 here, 3 and 1 4. This carbon has already completed tetravalency 3 this, and this one becomes 4. Here this carbon has completed single bond only, so we will put 3 hydrogen atoms to complete its tetravalency. And then if we count the number of hydrogen atoms, it will be 4. 1 2 3 and 4. And if we count the carbon number, which must be 3, we can see 1 2 and 3. In this manner we can write the structural formula of alkyne group. This is ethine, this is propine, next one will be butane, pentane, hexane, heptane, octane, nonane, decyne. This is also unsaturated hydrocarbon, because all the bonds are not single. In a hydrocarbon, if all the bonds are not single, then this hydrocarbon is unsaturated hydrocarbon. So the compounds of group alkyne are also unsaturated hydrocarbons, as we have seen that the compounds of alkene in the previous group, all the compounds are also unsaturated hydrocarbon. But the first one we have learned sometimes ago, alkane group. This was only saturated hydrocarbons because all the compounds were single. Now we will proceed to the next group. Now we will proceed to the next group, and this group is cycloalkane. This group is cycloalkane. Its formula will be like the formula of alkene group, but N will not start from 2, rather it will start from 3 and so on. And this is also not a open chain. Alkene group, and alkyne group. In all the groups, the linking between carbon and carbon was an open chain. It was not a closed chain. In structure, we see open chain and closed chain. Open chain is called the compounds of acyclic compounds or acyclic hydrocarbons, and in closed chain we call it a cyclic hydrocarbons or cyclic compound. Here, cycloalkane is a group of cyclic compounds. Here it starts from 3 carbons. If we have 3 carbons in a closed chain, this carbon has completed its valency only 2. So we will put 2 hydrogen at this carbon, 2 hydrogen at this carbon as well, and 2 also at this. In this manner, the number of carbon atoms is 3 and the number of hydrogen atoms is 6, which is twice the number of carbon atoms. And this will be read as its IUPAC name will be cyclo, and alk will be replaced by the number of carbon atom. The number of carbon atoms here is 3, for which we will write pro. This will be read as propane, cyclopropane. The IUPAC name of this compound is cyclopropane. If we put 4 carbons, and to complete the tetravalency of carbon, we will place 2 hydrogen atoms at each carbon, and in this manner, this number of hydrogen atoms is twice the number of carbon atoms. Here we see that there are 4 carbon atoms, so the number of hydrogen atoms must be 4 to the 8, and this it has been given here, and this will be read as cyclobutane. But for alk in this group, alk will be replaced by but, and so this word will be read as cyclobutane. In the similar manner, by using the number of carbon atoms, if we put 5 carbons in cyclic chain, this will be cyclopentane. If we put 6 carbon atoms, this will be called cyclohexane. So students, today we have studied hydrocarbons. We have studied 2 types of hydrocarbon: saturated hydrocarbons, in which all the bonds are single, and unsaturated hydrocarbon, in which all the bonds are not single, either there is at least one double bond or at least triple bond. Alkane group and cycloalkane groups are hydrocarbons, saturated hydrocarbons rather, because all the bonds are singular. But alkene and alkyne groups are all unsaturated hydrocarbons, because in these compounds all the bonds are not single. So students, we will meet next in the next class, and thank you for this.